Okay, today we will be looking at the relationship between delta G and nFEcell. Okay, so first, we write the formula out. Delta G equals to minus nFEcell. So your Gibbs free energy, if it's a negative number, it means the reaction is spontaneous. If your nFEcell calculated positive, it means that it's also spontaneous. All right. So this is nFEcell, not standard reduction potential, not the half, it's the full. Okay. Now F is your 96500, which is your Faraday constant. N would be the number of moles of electrons, okay, involved in the redox, not the half, the redox version. Okay, now something to bear in mind is that when you calculate out, you will calculate out to be joule per mole by default case. So please divide by 1000 to make it under kilojoule per mole unit. So a lot of students make careless mistake, forgotten to divide by 1000. Now, if the question gives you the other way around, okay, which means that if they give you delta G and they want you to work backwards to your nFEcell value, so take your delta G kilojoule number here, all right, make sure you multiply by 1000 first, then only you can work back to your nFEcell value. Okay, so that is the starting. Now let's take this question, summer 22, to start some simple practice. Okay, so ethanol is oxidized to ethanoic acid in the presence of dichromate ion. So ethanol, I can find ethanol here. It was oxidized to ethanoic acid. So obviously it's this half equation here. Okay, so ethanol was oxidized to ethanoic acid using dichromate in acidic condition. So dichromate is here. Okay. That means dichromate ions undergo reduction because he is more positive. So therefore, the ethanoic acid equation is less positive, will undergo oxidation. So they want you to construct the ionic equation for the oxidation of ethanol to ethanoic acid using dichromate in acid condition and calculate nFEcell. So we can see that dichromate involves 6 electrons. Ethanoic acid involves 2 electrons. So you want to go and multiply by 3 for the ethanoic acid. Okay, so if after multiplying, I believe the balance equation should look something like this. All right, dichromate plus 14H plus, all right, plus 3CH3CHO plus 3H2O to give 2Cr3 plus 7H2O plus 3 ethanoic acid and 6H plus. So we can simplify this 6H plus 14. We can make it to 8H plus on the left. 3H2O, I simplify here to become 4H2O. So this would be the ionic equation. So to calculate nFEcell is taking the more positive number minus the less positive number. And then you will be able to calculate out as a positive 2.27. All right, so that will be the nFEcell value. All right, so indicating that dichromate ion in acidic condition can oxidize your ethanol to ethanoic acid. Okay, now, so how many electrons are involved in this cell? 6. All right, 6. Okay, so because there's 6 electrons per dichromate ions involved. Now, next. In an ethanol oxygen fuel cell, okay, the ethanol and oxygen are in contact with 2 inert electrodes immersed in acidic solution. The cell reaction for the oxidation of ethanol by oxygen is shown. So you can see this is an nFEcell. That means it's a complex redox here. It's not half equation. It's a full balanced redox. Okay, and calculate the delta G. So first, we take the formula delta G equals to minus nFEcell. Okay, and we want to calculate delta G, right? Now, the question now that we need to address is how many number of moles are involved in this redox or in this cell. Okay, so we may have to look at more information from the table. Okay, do we have ethanol to ethanoic acid here in 1/2? Ethanol. We have ethanol and ethanol. We do not have ethanol to ethanoic acid, right? It's okay. What about oxygen and H2O? Okay, oxygen here and H2O. I can see oxygen and H2O. Correct or not? It's a 1 mole and 2 mole. I also see same thing, 1 oxygen mole and 2 water mole, right? So what we can see here is the oxygen has undergone reduction. Okay, oxygen undergo reduction by receiving 4 electrons. Reduction, okay, 4 electrons. Now, then it also means that your ethanol to ethanoic acid, okay, donated 4 electrons. Okay, now, so hence, to be a bit more specific, 2 ethanol donated 4 electrons. Can you see the 2 here? 2 ethanol donated 4 electrons. Therefore, per ethanol donated 2 electrons. Okay, per ethanol. I'm just going very detailed. But for the complete reaction, okay, 4 electrons were being donated by 2 ethanol, and the 4 electrons were completely received by 1 mole of oxygen. Okay, so what is the total number of moles of electrons involved? The answer here is 4. Okay, now, and then 96500, and then you multiply with the E-cell given, which is 2.01. What is the calculated answer? So the answer would be negative 775,860 joules per mole. Okay, now then I need you to convert it to kilojoule per mole. So if you convert to kilojoule per mole, it will be negative 775.9 kilojoule per mole. This would be the kilojoule per mole answer. Must convert to kilojoule. All right, so that's we start off with a simple calculation. Now, let's move to another example here. Summer 23. All right, now summer 23 over here. All right, given chlorine and iron 2 to iron 3 to give chloride ions. Given E-cell. So nice, they give us E-cell again. So you want to calculate delta G. So take out the formula. Delta G equals to minus nFEcell. Okay, now same thing we need to address. How many electrons are involved in this circuit or in this balance equation? So for chlorine to chloride, okay, this is 0, this is -1. 1 chlorine receive 1 electron, 2 chlorine receive 2 electrons. So this is a reduction. Okay, so hence we know 2 electron is being involved. If you check iron, right? Iron plus 2, 2 plus 3. Iron donated 1 electron, but because there is 2 iron, therefore 2 iron 2 plus donated 2 electrons to give 2 iron 3 plus. Okay, so there is 2 electrons being involved. So the answer here is 2. Now then you multiply, okay, by 96500, which is Faraday constant, E-cell given, which is 0.59. Okay, now, so what is the calculated answer here? Times 0.59, we will get somewhere minus 113,870. Please remember to convert to kilojoule, which is minus 113.9 kilojoule per mole, like this. Okay, so this is also a quite straightforward question. Okay, now continuing. Another experiment is set up using the same electrochemical cell. In this experiment, the iron 2 concentration is 0.15. All the other concentrations remain in their standard values. So iron 3 plus electron to give iron 2. I write in standard electrode potential. Okay, I write in standard electron potential or standard reduction potential format. This one here, we don't have the E value, right? Not given in the question, is fine. Okay, so this one normally is 1 mole per dm cube and 1 mole per dm cube. Standard condition. Now, so they said that iron now is 0.15, iron 2. So iron 2 now becomes 0.15. So the concentration of the iron 2 has decreased from 1 to 0.15. Okay, and all the concentration remain in their standard values. They gave us the Nernst equation. Thank you. But actually, you are supposed to memorize the Nernst equation on your own. Formula is not given. It's only this particular question they give it to you. Use the Nernst equation to calculate the electrical potential for the Fe3, Fe2 half cell, and they given the E theta is 0.77. Okay, so therefore, E equals to E theta 0.77 plus 0.059 divided by Z, where Z is the number of electrons involved, so only one electron involved here, so divided by 1. Okay, log oxidized divided by reduced. Who is the oxidized? Fe3 plus. Okay, Fe3 plus also is, I put the number 1 mole per dm cube. All right, Fe3 plus is just to tell you who is on top as the numerator. Now the denominator is the reduced species, the Fe2 plus here, and the concentration has reduced and now it became 0.15. So what is the E value over here? If we were to calculate this out, times 0.059 plus. Okay, so I've calculated out, the answer is positive 0.819. All right, so when you calculate out, right, you actually can self-check. Okay, originally, E theta over here is 0.77. Now, because iron 2, which is on the right-hand side of the equilibrium, they show a decrease in concentration of the product, which is Fe2 plus. According to Le Chatelier principle, all right, the equation will shift to the right-hand side to counteract the change. So when you shift right, you're undergoing a reduction. Hence, the E value after the counteracting action will be more positive. And I did calculated a more positive E number, which is 0.819. So you can self-check whether the calculation is correct or not. But of course, we cannot find the correct quantitative number, but I know the direction is correct. Either you calculate a more positive than 0.77 or you calculate to a more negative 0.77 version. All right. Now, moving on, use your answer to D1 to calculate E cell for this electrochemical cell. Okay. Now, D1 is just the answer above here. All right. How are we going to calculate E cell? Now, we have two half cell, iron 3, iron 2, chlorine and chloride. Okay, so I already know one, which is the iron 3, iron 2, 0.819. But the question now is I do not know what is the E value for the chlorine. I do not know this one. This one we need to investigate. All right, because to calculate the new E cell, we need two half cell. This is the first half cell we have. We need the second half cell first. Hence, we decide the more positive minus the less positive. But first, we need to go and find out what is the E value for the chlorine and chloride first. Okay, so how do we obtain the E value for the chlorine and chloride? Okay, now, so since above here, 0.59, okay, we know that this is 0.59, okay, so 0.59 is a more positive number minus a less positive E value, okay, more positive. It also means the reduction equation minus the oxidation equation. So in this equation here, okay, chlorine undergo reduction to chloride. So therefore, this is my question mark. This one is the reduction end in the equation given. Who was oxidized? Iron 2 in the equation was oxidized to iron 3. Do we have the E value for iron 2, iron 3? Is given down here, which is 0.77. Okay, so hence, I can put the 0.77 here. 0.77. So therefore, we can calculate what is the E value for the chlorine and chloride now, which is 0.77 minus, you minus a 0.59. Reduction minus oxidation. Correct. So winner minus oxidation, just give me a moment, 0.59. E value will come out to be positive 1.36. Wait, actually, okay. Right, that's correct, Liam. E value, so it's 0.59. It's actually 0.59 minus a minus 0.77. All right, so I need to shift this number over the other side. All right, so I come up with a positive 1.36. All right, so now I know what is the E value for chlorine and chloride, 1.36. Okay, so I bring my number here, positive 1.36. So since I already got the new iron half cell and the original chlorine half cell, between the two, who is more positive? 1.36. So the new E cell here, okay, without the theta symbol, because now your iron is not standard already, all right? Hence, when you calculate the E cell, it's also not under standard. So that's why there's no E theta cell, it's just E cell. More positive minus the less positive number, which is 0.189. Therefore, my new E cell is positive 0.541. Okay, so that is how you spice up the game a little bit. Okay, by using E values, E cell, and then delta G a little bit. All right, so that's the second example. Now we will go to another example here. Okay, this will be a third example. Now, this one is a very short yet 3 marks question. Okay, so just now that question was quite guided. This March 22 question is not really guided because they just throw the whole working in one statement. The question is just calculate the standard reduction potential of the vanadium, all right? Calculate the electric potential of the TiO2 plus / Ti3 plus, the E value in voltage, okay? And show you're working. They just put one question and you're supposed to figure out how to work about it, all right? It's not like a breakdown like 1 mark, or 1 mark plus 2 marks, okay? So this would be like a more challenging one if you have no prior practice, all right, for the second one. But I believe a lot of you still are able to handle it, okay? So let's look at this question here. You want to calculate the E value. You are not calculating E cell. You want to calculate the E value for the TiO2 and Ti3 plus. Let's start with some analysis here first. They've given us delta G, okay? And then this is 3 plus in terms of oxidation number. Titanium here would be, what is the oxidation number here for titanium? X plus -2 equals to +2. So X is +4. So the oxidation number of the titanium in TiO2 plus is +4. So we can see that titanium has undergone oxidation, okay, by donating 1 electron, okay, donating 1 electron here. Hence, we know that oxygen, okay, undergo reduction here. Okay, so we know exactly what role they play already. Now, they gave us the oxygen, okay, and the oxygen here given is positive 1.23. Okay, so I think more or less we know what to do. So first, delta G equals to minus nFEcell. So N, what is the number of electrons involved? So you can see here, one oxygen, correct or not? So oxygen requires 4 electrons. So hence I know in the complete circuit, right, they need 4 electrons here. And you can actually double check by looking at your titanium. One titanium don't need 1 electron. So 4 titanium don't need 4 electrons. So the number of electrons involved is 4. Correct? Yeah. And then your Faraday constant is 96500. E cell value is what we need to find. And delta G is given as minus 436.1. Okay. Now then, remember, now you want to work backwards, right? You need to multiply your number by 1,000. Okay. So now if you were to take the calculator, you should be able to calculate your E cell value. Okay. So let me just calculate out 436.1 times 1,000 divided by 96500. So you will be able to calculate your number to become a 1.13. I round up 1.13 volts. This is E cell. Okay, this is E cell. Now, E cell is a result of 2 half cell. Now, one of the half cell is 1.23, one of it. We need to investigate, which is the question now. What is the second half cell here? All right, which is the ETiO2 Ti3 plus. We need to investigate that one. Okay, so E cell is the more positive number minus the less positive number. It also known as the one who undergo reduction minus the one who undergo oxidation reaction. So oxygen has undergone reduction because you can see in the balance equation, oxygen was on the left, correct? 0. And then it becomes -2 on the right. So oxygen undergo reduction. So it means that we can take the 1.23 to put it at the reduction end, which is here. 1.23 minus oxidation. So titanium 3 plus was oxidized to titanium 4 plus over here. So your titanium E value, this is what you want to find, right? TiO2 plus slash Ti3 plus. So this is the E value that you want to find, right? So if you to rearrange your TiO2 plus slash Ti3 plus E value would be 1.23 minus 1.13, answer 0.10 volts. The end. Okay, you have to do step by step. All right, so first, you need to know who is the reduction and who is the oxidation end, because otherwise your 1.13 E cell, you don't know whether is it an X minus 1.23 or a 1.23 minus X. Okay, so there's many opportunities to make careless mistakes here. So please be careful. All right, so I selected a couple of few questions from the past year. Hopefully by now you can know how to apply delta G equals to minus nFEcell calculation. And if they try to ask the other way around, like this particular paper, then you more or less have an idea. All right.